Hi, my name is Ryan, and today we'll be looking at a lab experiment involving control volume, which will be studying the impact of a jet. A control volume is a volume in space surrounded by imaginary boundaries, which fluid may flow through. It is an arbitrary boundary that is often represented using dotted lines. For this experiment, we'll be studying on how fluid properties can be determined using certain laws or principles by setting a control volume. This is because a usual setup will involve a large radius of a surrounding, and without a boundary, principles such as Newton's second law cannot be applied accurately. With a control volume, in this case, we can study the reaction forces produced by change in momentum of a fluid flow when water jet strikes the surface. For the methodology of this experiment, a control volume will be set up, and the momentum force will be determined by measuring the reaction forces produced when the water jet strikes the surface. For this experiment, we will need only a hydraulics bench, a stopwatch, and the impact of jet apparatus, along with its flow deflectors. First, measure the diameter of the jet nozzle. Screw the 90 degrees deflector onto the end of the shaft. Then connect the inlet tube to the quick release collector on the hydraulics bench. Place the top plate on the transparent cylinder, and after using the spirit level to adjust the plate feed, tighten the 3 knurled nuts in sequence. Adjust the height of the level gauge until it aligns with the datum line and gently oscillate the pan to double check the gauge position. Place a 50-gram mass on the weight pan and open the bench valve slowly to allow water to impinge upon the target until datum line on the weight pan is at gauge level. Once it is leveled, leave the flow constant and jot down the flow behavior. Then we measure the flow rate by closing the ball valve and measure the time to accumulate a known volume of water in the volumetric tank. Repeat the procedure by adding additional 50-gram masses incrementally until a maximum mass of 500 grams. We can even simulate jet deflections at different angles using different flow deflectors. The data of the experiment can be recorded in a table, example as shown. From there, we can carry out the calculations for applied weight, flow rate, and the reaction forces. The applied weight and flow rate would be measured during the experiment, and since we have the flow area of the fluid, we can calculate fluid velocity using the flow rate equation. Then we can apply Newton's second law in the form of momentum equation. If we are considering just the point at which the jet strikes the surface, there will be no change in time, and leaving us to find out the reaction force at that instance using the equation F equals to mv. This even corresponds with Reynolds transport theorems of momentum's equation. As a conclusion, control volume allows for easier and more accurate analysis and calculations. The objective is achieved as we were able to calculate reaction forces produced by the water jet striking on the surface by applying Newton's second law momentum equation or the Reynolds transport theorem's momentum equation. And with that, thank you.